Okay, let me try to help you with one of the last topics in logic and computer science, which is the interpretation of the first order language. Sometimes it's kind a little bit confused, but let me do my best. In the difference between the first order language and the zero order language is that you can give a semantic interpretations. In the first order language, or in the test, will give you the next information. Well, that the logical constants has also variables, the first order language that has non-logical constants. Also, the first order language has terms and form. Then you can close it. That means in this part of the non-logical constants, we will have one element and we can put the number 1. This element is going to be a single parameter, which is the letter P. This is the predicate parameter, and in this exercise is just going to be as 1. Also, we will have one row interpretation. This can be represented with U and this symbol, which is row. This is going to be the interpretation. This interpretation is going to be with the letter U, and this is one set that has U1, U2, and U3. 3 members. Also, this has a mapping. This mapping has this a member parameter, and we will call P prime. Also, this information we will have semantic values. In alpha and the P alpha, don't worry if you don't understand this. This is just going to be the mapping that's going to be in the test. The teacher give you for sure. In the U1, U2, and U3, this is going to has values by default like 0, 1, 1. Don't worry, this is going to be changed depending of the test or the exercise. So let's review what do we have in this exercise. In this P prime, we will have one assign of the true value, which has just one element, and this one element we will have objects, which is 1, U2, and U3, 3 elements. According with this, we can do many exercise. I will going to put one a little bit difficult just to remember what you can do in some exercise. Suppose that in the logical constants has new members, which are the quantifiers. In this case, negation existential x, negation px. We can solve it. What is the first thing that you must do to give a semantic value? When I say a semantic value, that means you are going to give one value of true or false. Okay, semantic value is necessary, is the first part. So what do you need to do first? My best suggestion is do the truth, the tree of this. Go to the atomic formula in the first order language. So what is the subformula of this? So just take out the negation. So you will have existential x negation p px. That is the continue. Then continue with the 3. The 3 will be negation px. Okay, and then you can reach the atomic formula with px. This is going to be the atomic formula. Okay. So after that, let's do the mapping. In the mapping, we will have in the U, which is here, remember that we will have the 5 values. We will put this to here, which is the atomic formula Px. This is my best advice, and I'll tell you why. We will have some rows, that is U1, U2, and U3. In the atomic formula, we will have the values 0, 1, 1, which are the same. Okay? So we will finish this mapping. Let's put the another part here. Okay, which is negation Px. What is this result? Okay, let's just put the negation, which is 1, 0, and 0. Okay? With this information, we will take an account this as important. Now, the question is, here is one existential quantifier. That means, it's like ask you, is exist one true value here? Yes, here is. You have one true. So that means the semantic value of this part is 1. Because existential, you find something existent here, some true value, not here, not here. In U1 you find true. Now go up and there is one negation. In the negation you just negate this part. So this is the end of the exercise. Okay, what happens if we have negation universal x, negation Px? My best suggestion once again is do the same, do the tree construction, which is universal x negation Px. Let's continue with the tree construction, negation Px, and in the atomic formula we will have Px. What is next? Remember, do the mapping. So in the mapping we will have, remember, the U, which is represent this part, this alpha, and remember put the atomic formula here, which is Px. In the Px we will have rows interpretation U1, U2, U3, all the members that are here, U1, U2, U3. Okay, so let's put another values. Let's put another values. I will change this just because I want. I want to put 1, 0, 1, an example. Okay, so we will have this new interpretation 1, 0, 1. Okay, so let's put another information here. In the exam this will not change. I change because I want to give you another example definition. So let's put here negation Px, and the negation of this is going to be 0, 1, 0. Now the question is, universal, is every member you can find ones here? No, because you can find false information in U1 is false and U3 is false, just you can find in 1. So that means that the semantic value is going to be 0, because you will not find a truth in all the rows information. So the negation of this is going to be 1, and that is the end of this exercise.